Welcome back to Trick Equals Treat. Let's set the stage and look at our crime scene. We have a mysterious quadrilateral, A, B, C, D. Here are the clues we're working with. The diagonals cross paths at intersection point O. Segment AD is perfectly parallel to segment BC. We also have some secret twin lengths hidden in plain sight. Segment CD equals AO and BC equals OD. Oh, and our diagonal CA acts like a samurai sword, perfectly bisecting angle BCD right down the middle. Our ultimate mission? We are asked to find the exact measure of angle ABC. At first glance, it looks like a tangled web of lines. But don't panic. The trick here is to act like a geometry detective. We want to relate the angles with triangles so we can make use of their magical properties, like the fact that the sum of three interior angles in any triangle is always exactly 180 degrees. So let's assume that angle OCD equals alpha, angle ODA equals beta. Let's break the investigation down step by step. Step 1. The ninja slice. We start with diagonal CA bisecting angle BCD. That immediately gives us two perfectly equal angles to work with, angle OCD and angle OCB. They are equal to alpha. Step 2. The parallel slide. Because AD is parallel to BC, we can use the magic of alternate interior angles. They slide across the transversal line like a mirror reflection. Angle OAD is identical to angle OCB, and thus is equal to alpha. Angle OBC is identical to angle ODA, and thus is equal to beta. Step 3. Attack of the clones. Ha! Thanks to those equal angles, triangle ADC reveals its true identity as an isosceles triangle. Since it is an isosceles triangle, AD equals CD. Thus, AD equals AO. And the cloning doesn't stop there. Moving over to triangle ADO, since AD equals AO, boom, we have another isosceles triangle. In this triangle ADO, angle AOD is equal to angle ADO, and it is another beta. Step 4. The vertex kiss. Look at the center. Angle AOD and angle BOC are vertical angles, which means they are kissing at the vertex and are exactly equal. Angle BOC equals beta. This chain reaction proves that triangle OBC is also an isosceles triangle, making side OC equals side BC. Step 5. The domino effect. Since OC equals BC, and our original clues told us BC equals OD, we can easily deduce that OC equals OD, and thus angle ODC equals angle OCD equals alpha. We are literally connecting the dots. Step 6. The outside helper. Now look at triangle DOC. Angle BOC acts as an exterior angle to it. The exterior angle theorem tells us it's just the sum of the two opposite interior angles. Beta equals 2 alpha. Step 7. The grand finale. Setting up the final equation for triangle BOC is now a piece of cake. Look at triangle BOC. The sum of three interior angle is 180 degrees. Alpha plus 2 beta equals 180 degrees. When we solve the equations, we discover that alpha is exactly 36 degrees and beta is 72 degrees. Step 8. Sweet victory. Because angle OCD is 36 degrees, we find that angle DCB is 72 degrees and is equal to angle DBC. That makes triangle BDC an isosceles triangle too. So, side BD equals CD, and tracing it all the way back, BD equals AD. Thus, angle ABD equals angle BAD. In triangle ABD, angle ABD equals 180 degrees minus 72 degrees over 2. A little bit of calculation, we get angle ABD equals 54 degrees. We are asked the measure of angle ABC. Angle ABC is composed of angle ABO and angle CBO. So angle ABC equals 54 degrees plus 72 degrees. At last, angle ABC equals 126 degrees. Through an epic cascade of isosceles triangles and pure angle-chasing logic, we've cracked the code and found our angle. If you loved this geometry trick, hit that like button, subscribe to the channel to feed the algorithm, and drop a comment below on how fast you spotted the first isosceles triangle. Remember, in math, every trick is just a treat waiting to be discovered. See you in the next video. Trick equals treat.